So today we're going to talk about quadratics that are written in standard form. We're going to find the vertex, we're going to look at the axis of symmetry, and we're also going to find the y-intercept. You'll notice some similarities between today's lesson and the previous one, where our quadratics were written in vertex form. First, let's talk about what standard form is. If something is written in standard form, you're going to notice that it is ax squared plus bx plus c, meaning that we have a quadratic term, a linear term, and a constant. So when they're in the correct order, and they are written in this form, we can use this to find our axis of symmetry. Remember, yesterday I showed you that the axis of symmetry, we drew it as a dotted line that went vertically through the vertex of the parabola, and it cut your parabola into two equal parts. The equation for axis of symmetry is x equals negative b over 2a. You might recognize this as part of the quadratic formula. So if I fill in the parts, b in this equation is 6, so I have negative 6 over 2 times a, and a is 3. Simplify if you can. Negative 6 divided by 6 is negative 1. Now we have our equation for the axis of symmetry. This is a line. Anytime a line only has one variable, it means that it only crosses that axis. So this line is x equal to negative 1, which means I'll have a vertical line that only crosses the x-axis at negative 1. I'm going to make it a dotted line. Now the vertex will lie on this line. So one of the easiest ways to find the vertex is to take this x value and to plug it into our original equation. So everywhere that you see an x, let's put negative 1. Y equals 3 times negative 1 squared plus 6 times negative 1 minus 1. If you need to use your calculator, that's fine. Remember the difference between a negative sign and a subtraction sign. So as I put this in my calculator, I have 3 parentheses, negative 1 squared plus 6 times negative 1 minus 1. So that tells me that the value of y is negative 4. Now I have my vertex, and I can put that on the graph also. Negative 1, negative 4. I need to find my y-intercept. So just like we talked about yesterday, when a graph crosses the y-axis, x is equal to 0. So we're going to use that same method to find the y-intercept in this equation. Everywhere that I had an x, I'm going to put a 0. So I have 3 times 0 squared plus 6 times 0 minus 1. Now the good thing about zeros is it makes things go away. 0 squared is 0, and 0 times 3 is 0. 6 times 0 is also 0. So y is equal to negative 1. So that point would be 0 for x, y is negative 1. And that would be right here. Yesterday we talked about that every point on the right has a mirror image point on the left. So I automatically know that I'm going to have a point at negative 2, negative 1. And now I can sketch my graph. In number 2, we're going to follow these same steps. The first thing we're going to do is find our axis of symmetry. X equals negative b. My b term is positive 2, so I have negative 2 over 2 times a. A is negative 1. When I take negative 2 and divide by negative 2, I get a positive 1. So this time my axis of symmetry will be a vertical line that goes through x equals 1. My vertex will land on this line somewhere, so let's plug a 1 in for every x so that we can find out what y is. Notice I use parentheses everywhere that I am plugging that 1, and that's very important right here. When I square the 1, I am not squaring the negative that's in front of it. So this gives me 1, and then I put the negative on it, negative 1. I'll add that to 2, which is going to give me 1, and I add that to negative 5, which is negative 4. So when x is 1, y is negative 4. Now that I have my vertex, one of the other things you want to pay attention to is the direction of opening. This is going to be opening downward. So when I do my calculations for my y-intercept, it should be below where my vertex is. Let's plug a 0 in everywhere that we have an x. Now that we've done that, let's clean this up. All my zeros are going to go away, and I'm left with negative 5. So my y-intercept is at 0, negative 5. And just like we talked about before, I will have a mirror image point on the other side of the axis of symmetry. Now that I have my vertex and 2 additional points, I can go ahead and sketch my graph. These 2 examples have fractions at the front, which indicates that we are either going to have vertical stretch or compression. We're going to notice a difference because of these fractions. To find my axis of symmetry in number 3, I'm going to start off with my formula, x equals negative b over 2a. My b term is negative 1, so I have negative 1 over 2 times 1/4. Now, you may look at this and think, I don't think I can solve that by myself. You can use a calculator for this if you need to. If you're doing a fraction, we're going to do alpha y equals enter, and that puts the fraction bar into our calculator. We'll do negative parentheses negative 1, and in the denominator, I'm going to do 2 parentheses. I'm going to use that fraction bar again, alpha y equals enter, and I'll put my 1/4. Close your parentheses, and then you can hit enter. The answer is 2. So my axis of symmetry is at x equals 2, which means I'll have a vertical line that will go through the x-axis at 2. My vertex will land on this line. So let's use that value. When x is 2, what is my y? We'll plug it in. Y is equal to 1/4 times 2 squared minus 2 minus 2. Again, you're welcome to use your calculator, or you can do the mental math on this. If you're putting a fraction into your calculator, do alpha y equals enter. I've got 1 over 4. Then I'm going to have a parentheses. 2, close my parentheses and square it. Then I will subtract 2, and I'll subtract 2 again. That gives me an answer of negative 3. I'll go ahead and put my vertex on here at 2, negative 3. And now I'll find my y-intercept. To find my y-intercept, I'm going to plug a 0 in for x. So everywhere I see an x, make sure you use parentheses and put a 0. Again, since I have these zeros, those parts of the problem are going to go away. 0 times anything is 0. and my answer is -2. So that tells me when x is 0, y is -2. I'm going to have a mirror image point on the right-hand side. So I'll go ahead and put that here. And I can go ahead and sketch my parabola. In number 4, we're going to follow these same steps. We do have a fraction again, so we know that we are going to have vertical compression. This fraction also is negative, and that tells me that my parabola will be opening downward. To find my axis of symmetry, I will do x equals -b over 2 times a. Again, if you feel more comfortable pulling out your calculator to solve this, that is perfectly fine. This time we've got -4. Let's set up our fraction first. This time we've got alpha y equals enter -4 over 2 parentheses alpha y equals enter -2 over 3. Close your parentheses and hit enter, and you know that your final answer is 3. So this tells me that I have a vertical line that goes through the x-axis at 3. My vertex will be on this line, so I'm going to plug a 3 into my equation. Everywhere that I have an x, I'll put 3. Use parentheses everywhere that you plug this 3 into your equation. Again, you can pull out your calculator to plug this in. Make sure that you set it up exactly as you see it here. All right, let's plug this in. We're going to have alpha y equals enter -2 divided by 3. We'll put a parentheses down. 3, close the parentheses and square it. Plus 4, parentheses 3, and then -3. That gives us an answer of 3. So my vertex is at 3, 3. I'll put that on the graph at 3, 3, and now I'm going to find my y-intercept. Let's plug a 0 in for every x. I've got -2/3, 0 squared, plus 4 times 0, minus 3. These are going to go away, leaving just -3. So my y-intercept is at 0, -3. That would be here. Remember, there's going to be a mirror image point on the right-hand side. Make sure you count your units if you need to. The one on the left is 3 units away from the axis of symmetry, so the one on the right will also be. Go ahead and sketch your parabola, and now you're done.